All right, welcome back. Today we're going to talk about section 4.2, multiplying matrices. This will be the first day of this section. We've got a couple more that we will work through with that, simply because this is a skill that you guys will need to have, and it's a little different than stuff that you've done before. So we'll get you plenty of practice with this so that you guys are good at this. So what I've got on the board here, besides the title here, is I have A times B is equal to AB. This is how you're going to see the problems stated to you. Usually they're just going to have two matrices and two or three, and then they'll just put like find AB. So if I have matrix A, we need to know if we can multiply these, just like when we were adding and subtracting. Those had to be exactly the same dimensions. There's some dimensions restrictions that we need to have so that we can multiply. So if I say that matrix A is an M by N matrix, whatever size that is, and I'm going to say that matrix B is going to be an N by P. In order for us to multiply these two matrices, these two, the ends, must be equal. So remember, this is going to be the columns of A and the rows of B. Those need to be the same. So if they're not the same, we can't multiply these. So we would just simply state that. So that's how you check to see if you can multiply. If they are equal, the outside numbers, these are going to give you your dimensions of AB, that matrix that you're going to get when you multiply that. So A times B in this case is going to be an M by P matrix. So you're going to take your columns of A or your rows of A, rows of A and your columns of B, and that's how big your new matrix will be. So I know with the letters that makes it a little fuzzy. So let's take a look at some examples here real quick. If I have matrix A as a 2 by 3 and matrix B as a 3 by 4, so I like to write these out by each other, 2 by 3 and 3 by 4. So I look. These middle numbers right in here, they're the same, so we can multiply these. So this is okay, we're good to go. And our dimensions of AB are going to be our outside numbers, and we're going to get a 2 by 4 matrix. So I've got 2 rows, 4 columns, and that's going to be the size of that. If we take a look down here at problem B, again, like I said, I like to write them out. It makes it a little clearer for me. 3 by 2 and 3 by 4. Again, I look to my middle numbers. 2 and 3 are not equal. So this, as our problem says, tell whether it's defined. This is what is going to be not defined. Be careful with these on your homework and stuff. This is a way to check to see how well you know your multiplication of matrices, because it's easy to sneak one of those in there and have them be not defined, meaning that you can't multiply those two. So since you can't multiply them, you don't have to worry about having the dimensions of AB. So the real question that I know you guys are all wondering is, if I have two matrices, how am I going to multiply these two? So first of all, let's check to make sure that we can. Again, easy to overlook that. So I've got in A, I have 3 by 2, 3 rows, 2 columns. B is a nice square matrix for us, 2 by 2. So since our middle two numbers are the same, 2 and 2, we can multiply, and we know that we should end up with a 3 by 2 matrix at the end. So I'm just going to copy down A and B here. 2, 1, 6, and 3, negative 4, 0. I'm going to multiply this by negative 1, negative 2, 3, and 4. So, the biggest mistake I see people do is they're going to try and multiply entry by entry. So they're going to take that negative 1 times the negative 2 in the left-hand side. They're going to take the negative 2 from the left-hand side and multiply it by the 1 on the matrix on the left, matrix A. But that's not how we're going to do this. The way I imagine it is almost more like a drag and drop from a computer. I am going to grab this entire column right here, and I'm going to drag it over, and I like to put it on top of my matrix A. So it's going to shift over, and it's going to rotate as well. So the negative 1 is going to go up top here, and the negative 2 is going to go over that second column. The reason I do that is because now we can just drop that multiplication down the rows. So the negative 1 is going to multiply every number in that row, or that column, and the negative 2 will multiply every number in that column. So I end up with negative 2 times negative 1, 1 times a negative 1, and 6 times a negative 1. And now this part is going to be a little weird. We're going to do the same thing with our 2, with our negative 2 up top there. But in between these, we're going to add these two together. So we're going to add a 3 times a negative 2, add a negative 4 times a negative 2. We're going to add a 0 times a negative 2. So we've done the first column of B multiplied by A. Now we need to do the next column. That will again go up top there. We're going to move the 3, that's up top. That's the farthest, that's closest over there. And our 4 is going to go over there. And now here's where you split, you're multiplying by a new column. So this is where you're going to make a new column in your next matrix. And then it's the same idea. So we're going to take negative 2 times 3, 1 times 3, and 6 times 3. And we're going to add on the second column. So 3 times 4, add on negative 4 times 4, and add on 0 times 4. Now, once I simplify these, everything in blue, that's just going to be one column. Everything in green is going to be another column. And notice I needed 2 columns at my end. This is how I'm going to get that. From here, now it just becomes your basic math skills. We multiply. Negative 2 times 1 is going to give you a positive 2, plus 3 times 2 is a negative 6. Negative 1 times 1 is negative 1, plus negative 4 times negative 2 is a positive 8. Negative 6 times negative 1 is going to be negative 6, plus 0 times negative 2 is going to give me 0. In green, negative 2 times 3 is going to give me a negative 6. plus 3 times 4, which is 12. 1 times 3 is 3, plus negative 16. I like to put those in parentheses just so I can keep that straight, that I don't lose that negative. I've got a habit of doing that. 6 times 3 is going to be 18, and 0 times 4 is 0. And then you're just going to simply add your two numbers together. So on the left-hand side, 2 plus negative 6 is going to give you a negative 4. Negative 1 plus 8 is negative 7. Negative 6 plus 0 is negative 6. Oh, 1 plus 8, negative 1 plus 8 should give me a positive 7. Then on our right, negative 6 plus 12 is going to give me a positive 6. Negative 3 plus negative 16 is going to leave me with negative 13. And 18 plus 0 is, of course, 18. And there is your matrix AB in black there. That'll be your final answer. One more for you today. If A is this matrix, B is this matrix, we're going to find the products. First of all, AB. So that means I am going to multiply 3, negative 1, 2, and 0 times 1, 2, negative 4, 1, and see what I get. Again, same process. They're 2 by 2, both of them. So we should end up with a 2 by 2 at the end. So again, I'm going to take this whole row here, or this column. I'm going to put it up top. 1, 2, and I multiply. I get 3 times 1 and negative 1 times 1. Then I'm going to add on 2 times 2 and 0 times 2. Go to my next column, negative 4 and 1. So I'm going to get 3 times negative 4, negative 1 times negative 4, and I'm going to add on 2 times 1, and I'm going to add on 0 times 1. Simplify that down a little bit. I'm going to get 3 plus 4, negative 1 plus 0, and I'm going to get negative 12 plus 2, and 4 plus 0. Simplify down, 7, negative 1, negative 10, 4. So there is your AB. So when you multiply those together, that is going to be the matrix that you get. Now, we're going to look at B times A. So same problem, same idea, same concepts, but now instead we're going to look at 1, 2, negative 4, 1 times 3, negative 1, 2, and 0. Again, I'm going to multiply this column. I'm going to move it up top, 3, negative 1. So I'm going to get 1 times 3, 2 times 3, plus negative 4 times negative 1, and plus 1 times negative 1. And again, move this over. So we're going 2 and 0. So I'm going to take 1 times 2 and 2 times 2. I'm going to add negative 4 times 0 and 1 times 0. Simplify down here. I'm going to get 3 plus negative 4 times negative 1 is going to give me a positive 4. And I'm going to get 6 plus a negative 1. And on the right column, I'm going to get 2 plus 0 and 4 plus 0. Simplify down here one last time, and we should get to what we need. 7 negative 6 plus negative 1 is going to give me 5. 2 plus 0 is 2, and 4 plus 0 is 4. All right, so as you guys can see, since I use the same numbers, same problems, all I'm going to do is all I'm doing is switching the order on what I multiply, but I get two different answers. So our 7s are the same, but negative 10 is not equal to 2. So they are not going to be the same answer. So pay attention to that order. It really does matter. This last problem, I'm not going to work all the way through it, but what we're saying here is in part A, we're going to multiply A times B plus C. So this one, what you want to do is pay attention to that addition sign right there. I would add B plus C, so you're going to get 2, negative 1, 1, and 3 times B. Negative 2 plus 1 is going to give me negative 1. 4 and 3 are going to give me 7. 0 plus 1 is 1, and 2 plus 2 is going to give me 4. Multiply those out, see what I get. And now I'm going to multiply in B. You're going to multiply A times B, then add it to A times C, and see what you get. If you guys want to work through that, that is up to you. I'm not going to make you guys watch a longer video of me multiplying out some more matrices. But what you will find is you'll find out whether the distributive property works or not. And you will find that it does, as long as you handle it in the correct way. So thanks for watching again. We'll work some more on this in class. I know this is something different from what you guys have done before, so we'll get plenty of practice with that. Keep talking to me, letting me know what's going on, and we'll go from there. See you guys in class.